welcome back from your summer. Hope it was good. But now it's time for grade 9. So we'll start our first lesson 1.1. It's called Square Roots of Perfect Squares. And it's on the first unit, Square Roots and Surface Area. So what I'd like you to be able to do with this at the end of this lesson is to be able to take a look at a fraction or a decimal and tell me whether that fraction or decimal is a perfect square. So let's take a look at the first part right here. Let's scroll up. Consider the following square with an area of 100 centimeters squared. What is the length of that side? Well, if you take a look, you can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that's 10. And of course, it's a perfect square, so that's 10 by 10. So what is the length of the 10? Well, it's 10. We're working in centimeters, so it's 10 centimeters. How would you find the length of the side if you didn't count? Well, we know this is 100 square. That means we have to figure out how to get from 100 to 10. If you go back to grade 8, you would remember that the square root of 100 is 10. Or you could remember your times tables and know that 10 times 10 is equal to 100. So you can find it that way. Now, is 100 a perfect square? In grade 8, we learned that if you have an area of a square and the side lengths were whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with no decimals, then it is a perfect square. So is this a perfect square? Yes, it is. How do I know that? The side length is a whole number. Okay, so let's get you some practice on your calculator. Using your radical sign, or the square root sign, I want you to find the square root of these 4 numbers. So pause the recording and do that. All right, so the square root of 225 is equal to 15. The square root of 169 is equal to 13. The square root of 324 is equal to 18. And the square root of 25281 is equal to 159. What do you notice about all of these 3 square roots? Well, you should notice that they're all whole numbers. So because they're all whole numbers, that means that all of these numbers right here are perfect squares. So the square roots prove the original number is a perfect square. Hopefully you can read my writing. Okay, next page. So here's a quick problem from grade 8. We've done this one quite a few times. A playground has an area of 400 square meters. How long does a fence have to be to completely go around the outside of this playground? So we need to find what is in essence the perimeter of this square playground. The first step we have to do is to find one of the side lengths, and to do that you find the area of 400. So side length, I think I said area, square root of the area. Side length is equal to the square root of the area. So we know our area is 400. The square root of it means that my side length is 20. So that means that this is 20 and this is 20, and as are those. So we have 4 of them because it is a square. So to find the perimeter, well, you multiply the side length by 4. We multiply it by 4 because there are 1, 2, 3, 4 sides to a square. So my perimeter is equal to 20 times 4, which gives me 80. And we are working in meters, so it's 80 meters. Now, that means that 400 is a perfect square because our 20 is a whole number. Let's take a look and change the question just slightly. What if 390 was my area. So to find the side length, we have to find the square root of 390. And you'll notice that this time, the number is not a whole number. It's actually 19.74, 8417. So to find the perimeter of this, I've got to take 19.74, 8417, multiply that by 4, keeping it in your calculator, don't round it yet, and that will give me 78.993670 meters. Now that you have your final answer, you can round it off to 2 decimal places. Don't round this one, because when you round this one, you're going to create a little tiny of a mistake here when you round it. You change the number. When you multiply the rounded number by 4, you take the mistake and you make it 4 times bigger. And that can sometimes change your decimals. So only round at the very end. So how are these two responses different? Well, the first one, the 400, was a perfect square. Okay. And the second one, the 390, is a non-perfect square. And we know this because the side length of this one was 20, which was a whole number, and the side length of this one was 19.74, or I guess it's 75 when you round it off properly from up here. So 19.75, it's non-perfect because it actually is a decimal. Okay, so now that we've done the grade 8, let's take a look at the grade 9 stuff. We have to get away from whole numbers now and work into decimals and fractions. So here we have the same thing we had a minute ago. This is a 100 square. But now this 100 square has been shaded. So what fraction of this has been shaded? Well, if there's 100 out of 100 squares, that means it's 100 out of 100. That would be how many are shaded. So how did I get this? Well, there are 100 shaded out of a total of 100 squares. It's a simple fraction. So how do you find the number of squares that are shaded without counting? Well, to do that, you just have to, again, go back to the fact that 10 times 10 is equal to 100. Okay? Or if you wished, you can go back to the square root of 100 is equal to 10. Either way, that's how you can get to your side length without counting. Now, what if we reduce the size of our fraction? Now I don't have a 10 by 10. I have a 10 by 10, I have a 100 square, but the amount that is shaded is reduced. So what fraction of the square is shaded now? Well, this here is a square, and that square, to find the area of that, would be 9 times 9. The area of the large square we still know to be 10 times 10. So this fraction, which is shaded, is 81 out of 100. So how do you find the shaded squares and side lengths of them? Well, we just simply took this one here and we counted it. And we took that side length and we multiplied it by itself, and that gave us the shaded area. So 9 times 9, giving us 81. So what is the length of each of these? So if I wanted to find a length, we know the total length is 10. So what you want to consider is just from here to here, the first set of blocks. Now we know that we have 9 shaded out of 10. So there's our fraction of our side this time. And of course, across the bottom, it's the same thing. There are 9 out of 10 which are shaded there. Now to find the area of the shaded square, we now have to take a look and do length times width, which will be 9 over 10 times 9 over 10. So this is how you find the area. Well, if you remember back to multiplying fractions, to multiply a fraction, it's the top the numerator multiplied by itself and the denominator multiplied by itself. So there you get 81 out of 100. Now you should notice that that's exactly the same as we got a second ago on our previous one. 81 over 100. This way we counted them, whereas here we multiplied the fractions to make it work. So let's reduce it again. Now the area is going to be this distance out of this distance. So that gives me 8 out of a 10. And of course this is 8 out of a 10. So what is the area? Well, find the area of a rectangle. You take the area of the side and multiply it by the area of the side. So that gives me 8 times 8 over 10 times 10. That gives me 64 over 100. So what if we didn't have the grids to count? We just had 2/3. So what's the area of this square? Well, we're going to follow the same process. We can't count it, but we do know the dimension is 2 out of 3. So to find the area, it's going to be length, which is 2/3, times the width, which is also 2/3. It's a simple rectangle. So 2 times 2 over 3 times 3 gives us 4 over 9. So there is my area. So let's take a look at what we've done here. We have found the area. We have found that finding the area of a square is the same process, even if it's a fraction. So taking a look at this, let's fill in what we know. 20 squared was 400. 100 for 10 over 10 was 100 over 100. 9 over 10 squared was 81 over 100. 8 over 10 squared was 64 over 100. And 2 over 3 squared was 4 over 9. So in general, can you tell how you find the area of a square? Well, in all of these cases, we took the side length and squared it to find the area. So in all cases, the area was equal to the square of the side length. So if you know the side length, square it, you will get the area. Okay. Now, what I'm going to do here is I'm going to turn you loose on a little bit of an exercise. I want you to find the area as a product. Remember, the area as a product as in two numbers multiplied by each other. And then what is the side length as a square root? So I'm going to want you to, well, actually I'll do the first fraction one for you. Okay. So this becomes a square root of 49, which is 7 over 10 times 7 over 10. All right, that gives me that the square root of 7 over 10 is 49 over 100. Sorry, it's equal to the square root of 49 over 100. I'd like you to go through and calculate the area as a product, as well as tell me what the side length is in a square root form. So complete this table. Pause the recording and do it, and then in a second we'll fill it in. Okay, so here we go. 8 times 8 for 64. That means the side length is a square root of 64. 8 over 10 times 8 over 10. That means that the square root is 64 over 100. And of course 121 is 11 by 11. And that means that the side length is the square root of 121. This becomes 11 over 10 times 11 over 10. And that means it's the square root of 121 over 100. And of course 12 by 12. And this is the square root of 144 over 100. And of course this is 12 over 10 times 12 over 10. And that means it is the square root of 140. Oh, sorry, I messed up here. Just noticed that I glanced down at the wrong one here. This is the square root of 144. This one here is the square root of 144 over 100. Okay, so we played around with a lot of the square roots and the fractions, and you should have noticed something about every single one of these. And that is that all of our numerators and all of our denominators are whole numbers. So let's take a look at mixed fractions and see if we can figure out how to get a mixed fraction to determine if it's a perfect square. So I've got the area of this is 196 over 100. So what is the side length? Well, every time we did this, we square rooted to find the side length. So to find the side length, we have to calculate the square root of the area. Now we know the area is 196 over 100. So what is the side length? We want to square root the area. Okay, well, how do we do that? Well, we got the square root of the area. That's 196 over 100. That is the same as finding what number multiplied by itself gives you 196 over 100. So we're really asking for the square root of 196 and the square root of 100. So this becomes, if you break it up, 14 over 10 times 14 over 10. So the side length is 14 over 10. So if I have an area of 196 over 100, the area is like side length is going to be 14 over 10. Now let's go back then. I want to go back and take a look at all of this stuff now so we can compare this to perfect squares. All right. Now we know that 400 is a perfect square because this here and this here, its side lengths, are whole numbers. How does that apply to a fraction? Well, in fractions, it's the same thing. 100 is a perfect square. That means that's 10 by 10. This one on the bottom is also a perfect square because it's 10 by 10. So if you take a look, if we know this is perfect because it's just 100, it's 100 square, then we know that this is 10 out of 10. We know that this is 10 out of 10. You take a look at your numerator and your denominator, and in both cases, these are whole numbers. So if you want to find out if a fraction is a perfect square, you have to square root the numerator and square root the denominator to find out if they are whole numbers. Or maybe you could recognize that the numerator and the denominator are perfect squares. If you can, then that fraction is a perfect square. So look at this one with 9 over 10. 81, that's a perfect square. And this one here, 100, is a perfect square. Because of this here, this is a perfect square. If you go down to 8 over 10, we know 64 is a perfect square. And this one here, 100, is also perfect, so that makes 64 over 100 a perfect square. 2/3, 4 is a perfect square, 9 is a perfect square, that means 4/9 is a perfect square. So if you look at every single one of the ones we did here, every one here, every single number in that whole column is a perfect square. So a general statement, how could you tell if you found the area of the square? In all cases, the area was equal to the square of the side length, and in this case, they were all perfect squares. Now, we've gone over that. Let's take a look. Come on, machine, do your thing. My smartboard just stopped working for a second here. All right. Okay, let's go to 196 over 100. It's the same thing if you take a look. The side length is it's 14 over 10. They're whole numbers, both of them, 14 over 10. And that means that 196 over 100 is also a perfect square. Okay. Now, going down to the next part. Let's complete the problem with a fraction in decimal form. So this is to prove to you that you can also have perfect decimals. Now we know that now 196 over 100, we know that we just proved that this is a perfect square. This fraction is perfect because 196 is a perfect number and 100 is a perfect number. They both have square roots, which are whole numbers. Okay? That's supposed to be a 10. Now let's go over here. How do you change a decimal into a fraction? Well, to do that, you go 196, you take the numerator, and you divide it by the denominator. And that gives you 1.96. Now, if we know that this is a perfect number, and we know that this here is just the decimal form of our fraction, this here should also be a perfect number. Well, let's take a look. We know this is 1.96 squared units. So how do you find the side length? Well, we know you take the square root of the area. Okay. So if you find the square root of the area, the square root of 1.96 is equal to 1.4. So how can we tell from 196 and getting 1.4, how do we know that 1.96 is a perfect square? Well, just hold that question in your head for a couple of minutes, and we're going to go on and do a couple more, and maybe when we do the examples of it, it'll actually work out. So what is the square root of 1 over 81? Well, find the square root of 1 over 81. You take the square root of 1 over 81. That means you have 1 times 1 over 9 times 9. That's your square root, which means we have 1 over 9 is our square root. Okay. Now, we notice that this is a perfect square. And we know that this is a perfect square. But what is 1 divided by 9 in decimal form? So we know that this one here repeats. And we know that this one terminates. All right? So this is our clue. A fraction in simplest form is a perfect square if it can be written as the product of two equal fractions. Two equal fractions. All right? I'm going to add a little bit more to this. You can also say, or the numerator and the denominator are both perfect numbers. Okay? The numerator, that's the top number. Okay, and to do that, go back to 196 over 100. Both of these were perfect. So that means that that is a perfect fraction. Now the decimal is a perfect fraction. Sorry, when a decimal can be written as a fraction, that is a perfect fraction. Or perfect square, sorry. And then the decimal is also a perfect square. I guess you'd call it a perfect decimal, but this works. Now, there's also another one, which is probably easier than trying to convert a decimal into a fraction. If you take the square root of a decimal, right, and it's a perfect decimal, then the result will be terminating or it will repeat. Okay? Now, if you're not quite sure or don't quite remember what a terminating decimal looks like, terminating decimals are all decimals that have an ending. They stop. So 1.2, that stops. 1.4, that stops. 32.7487 stops. These are all terminating decimals because they terminate or they end. Now, a repeating decimal is one that has a period, or what's called a group of numbers, that repeats. So something like 1.333, which continues on forever. Sometimes we write this as 1.3 with the bar over it, but it repeats and goes on forever. Sometimes the numbers can be groups of numbers like 1.525252, or we go 1.52 and put the bar over the 52. These are both repeating decimals. So they would also be, if this was the square root of a number, that number would be a perfect square. Now, numbers or decimals which neither repeat or terminate, they're called irrational numbers, and pi is probably the most common one that we know about, right? And sometimes with a calculator it's difficult to determine, so you got to be careful and just look closely. But if you had something like that looked like this, you could look at that and you'd find that there's nothing in there which gives you any indication that this is actually a repeating decimal. If it was, then you probably would find something start to repeat. But in this case, there's nothing to tell you that. So this one here does not repeat or terminate. Now on some of our calculators it's a little bit more difficult to figure this out because you never know if the last digit is actually being rounded or not. So just be careful, watch, it should be clear. So here we go. So what I want you to do, here are a bunch of fractions. I want you to identify which one of these fractions are perfect, and I want you to give me the reason for it. All right, so take a look, pause the recording, and do these examples. All right, so 25 over 64. So 25 over 64, 25 is 5 by 5, 64 is 8 by 8. So since the square root of 25 and the square root of 64 are both perfect or whole numbers, that means that this is in fact a perfect square. And to explain it, both 25 and 64 are perfect squares. All right. Now 27 over 36. Well, if you take a look at 27 over 36, the 36 is 6 by 6, but there is no number you can multiply by itself which is a whole number that'll get you 27. The lowest one would be 25, which is 5 by 5, and of course above that is 6 by 6. So this one is not a perfect square, so it's no, because 27 is not perfect. All right, let's take a look at 121 over 81. 121, the square root of 121 is equal to 11. The square root of 81 is equal to 9. Since 11 and 9 are both whole numbers, that makes 121 and 81 both perfect squares. So the answer here is yes, 121 and 81 are perfect. All right. 1 and 9 over 16. Well, we got a mixed number here, so before we can do anything, we have to change it into an improper fraction. So that is 16 times 1 plus 9, and that will give us 25 over 16. Now 25 is 5 by 5, 16 is 4 by 4, so yes, this one is perfect because 25 and 16 are perfect squares. Well, my computer just had a short little break here. So I'm going to have to pause this for a second and wait for it to recover, and then I'll be right back. Okay, looks like everything is good to go here. We're back up and running. So 25 and 16 are both perfect squares, so 1 and 9, 16 is a perfect square. Now for 32 over 50, you got to be careful, because the first thing you should notice is that 32 over 50 is not a reduced fraction. So if you take 32 over 50 and you reduce it by dividing both by 2, you'll get 16 over 25. And we know that 16 over 25, by looking up here, 25 and 16 being both perfect squares, we know that 16 over 25 is just its reciprocal. So this means that yes, this is also a perfect square because 25 and 16 are both perfect squares. So now you should be able to take a look at a fraction and determine why it's a perfect square. And that's because that it has a numerator and a denominator which are both perfect. All right, let's take a look at a decimal. Well, there's a fraction method, and then there's the decimal method. The fraction method is a lot of work, but you can do it. You take and convert this 1.44 into a fraction. Well, since this 4 is in the hundreds place, this is 1 and 44 100ths. Right? Now, you take and change that into an improper fraction. That gives you 144 over 100. So now we know that this here is 12 by 12, and this is 10 by 10. So we have a perfect square. Both 144 and 100 are perfect. Well, there's another way of doing it, and that is just to take your calculator and find the square root. Okay? So find out, you want to know if the square root, if it terminates or if it repeats. So the square root of 1.44 on your calculator will give you 1.2. 1.2 terminates. So 1.44 is a perfect decimal, or perfect square. So you should be now getting to the point where you can do this. All right, so let's take a look at the next question, and I'd like you to try this yourself. So see if you can fill in the blanks to tell if 1.96 is a perfect square. So pause the recording and do that one. Okay, so 1.96, I'm just going to convert this right into 196 over 100. Convert it into a mixed fraction, which would be 1 and 96 over 100, and then turn that mixed fraction into an improper fraction. Now, this 196 is 14 by 14 and 10 by 10. So since 14 and 10 are both whole numbers, then those being the square root of 196 and 100, we know that 1.96 is a perfect square. If you do it the decimal method, it comes out the square root of 1.96 is 1.4. So yes, this is a perfect square also because 1.4 terminates. Okay, here's another example for you to try. Identify which of these, and you can do both of them, are perfect squares by both methods. So pause the recording and complete this. Okay, let's take and convert everything into an improper fraction. 28 and 9 over 100 gives you 2809 over 100. This is 53 by 53 and 10 by 10. So using the fraction method, both the numerator and the denominator are perfect squares. So that means, yes, 28 and 9 over 100 is a perfect square. Taking the square root of this gives you 5.3. So it terminates. So it is a perfect square. All right, let's go down to 6.4. 6.4, well, as a decimal, or sorry, as a fraction, that's 6 4/10. That gives you 64 over 10. Well, the 64 we know is 8 by 8, but there's no number multiplying by itself which will give you 10, which is a whole number. So we know that this one, since the denominator is not a whole number, after you square root it, I shouldn't say the denominator is not a whole number. Let's fix that. The denominator is not a perfect square. Let's fix that. Because the denominator is not a perfect square, 6.4 is not perfect. Okay, root 6.4. Well, if you take the square root of 6.4, you're going to get 2.529822128, and it goes on. If you look at that, there's nothing in there that gives you any idea that it actually is going to repeat. So in this case, it does not repeat or terminate. So it is not a perfect square. Okay, let's take a look at our question. Let's have you pause the recording and complete this. This is very similar to the first one we did. All right, so solution, we have to find the area. So the side length is going to be equal to the square root of 38.44. That means that my side length is going to be equal to 6.2. That means my perimeter is going to be equal to 6.2 times 4. That means my perimeter is equal to 24.8 meters. Now the question I have for you is 38.44 a perfect square? Well, if you take a look at what we did here, we found the square root of 38.44, and that was 6.2. 6.2 terminates, so this is a perfect square. All right, so the perimeter is 24.8 meters, which is a perfect square. I should say not the 20 point, the 38.4. 4 is the perfect square. Okay? All right. Now, I'd like you to try something which will stretch your brain a little bit. A square on a piece of paper has an area not less than 15.21 centimeters and not greater than 20.25. So if those are the two things, what is the smallest side length that you can have? What is the greatest side length you could have? And then I want you to tell me, if a student determines the square has an area of 18.0625 centimeters, what is that side length? So pause the recording and see if you can figure this out. All right. Well, the least possible side length would come from the least possible area. So the area cannot be less than 15.21, so the least possible side length comes from the square root of 15.21, and that is equal to 3.9. So that means that the least possible side length is 3.9 meters. You can't go less than that. The greatest possible one, we'll take a look at the largest possibility, so I need the square root of 20.25, and that would mean that the greatest possible side length would be 4.5. I guess I'm in centimeters, so this should be centimeters. So a student determines that a square has an area of 18.0625. What is the side length? Well, to find the side length, you have to take the square root of 18.0625. That means that your side length in this case is going to be equal to 4.25 centimeters. Okay, so that's the end of the lesson. It's time for you to start your assignment, and we will see you in 1.2.